This is lesson 9, lift sources other than thermals, specifically ridge lift, convergence lift, and wave lift. So previous lesson we talked about thermals and how to utilize the thermals which cause rising air to gain altitude in the glider. But thermals aren't the only reason that air in the atmosphere rises. This lesson is going to be a very brief introduction to some of the other phenomena that cause areas of rising air. I personally have, what I know about these different types of lift is basically book knowledge, which I'll try to pass on. But I don't have a lot of personal experience with it, so this lesson is going to be a very superficial introduction to these types of lift. In areas of the country that have good ridge lift or good wave lift, it's common for glider clubs in those regions to periodically organize, ridge camps or wave camps where local instructors have guests come and make a point of teaching them how to utilize that type of lift and familiarize themselves with that area. Even if you are familiar with ridge soaring or wave soaring in one region, if you move to a different region, it's still very useful to get together with a glider flight instructor from that region to find out some of the unique features of that region. So today's lesson we'll talk about ridge lift, convergence lift, and wave lift. So ridge lift happens when wind blows up a slope. It's best when the wind is perpendicular to the slope and when you have a kind of a long mountain ridge so that there's quite a bit of area or distance that you can fly where the ridge lift will be present. The best lift is kind of concentrated in a little area right along the face of the ridge that the wind is coming up. There's lift in a wider area than that, even up above the lift, but the strongest lift tends to be very close there to the ridge. When you enter the zone of lift and you're coming from the direction that the wind is coming from, you have to be very careful about how you approach that lift zone. You want to come at an angle like this glider on the right is doing, where they come at kind of a shallow angle to the ridge and then turn and get themselves into a crab angle. The tendency, if you think you're going to be able to make a normal turn in that situation, since the wind is blowing towards the ridge, you'll be going faster into the ridge than you expected, and you could hit the ridge. On the opposite side of the ridge, oftentimes there's a lot of sink. It's not good to try and get into the ridge zone from that side. Of course, it also does depend on some of the local terrain and specific conditions at that particular site. So there are rules for avoiding each other in around a ridge. These are somewhat different than the standard collision avoidance rules. Sometimes the standard rules wouldn't make sense when you have the constrained area that you have when multiple gliders are both trying to work the same ridge. One rule, you want to make your turns away from the ridge when you're changing directions. Obviously, if you're starting close to the ridge, you don't want to turn toward the ridge to change directions or you will be in the ridge. When two gliders are approaching each other head on, the glider with the ridge on the left should yield to the other glider. Should do that by moving out away from the ridge into an area that is, they'll move into an area that's not as good of lift for a moment, but that's a lot better than getting too close to a collision. When one glider is overtaking another glider, the best approach is for the glider that's doing the overtaking to switch directions and not overtake the other glider. You will find some references out there that say that you should pass the slower glider on the ridge side. But that isn't the current advice. That's old advice. So when you're soaring near mountains, whether it's because you're trying to use ridge lift or wave lift, or because you're even if you're thermal soaring in the mountains, there are some special considerations related to being in mountainous areas. The wind can shift directions dramatically from over short distances, both directions horizontally and you can get a lot of vertical wind, including very strong sink on the downwind side of any ridge. Mountainous areas have a lot fewer good outlanding areas, so you have to be even more conscious about where you would go if you don't find good lift when you are soaring near mountains. And density altitudes are likely to be high, even mostly because the pressure altitude is high. And even in the valleys, they tend to be pretty high density altitudes. That translates to you having higher true air speeds. You need longer distances of runway for takeoff and for landing. So near mountains, in addition to finding ridge lift, it's also likely that there will be some decent thermals near mountains. It happens that the sun tends to shine on one side of the mountain and not shine on the other side of the mountain during part of the day. When that's true, the air will tend to be moving upward on the side of the mountain where the sun is shining and downward on the other side. A second type of lift other than thermals is convergence lift. This happens when there are two masses of air that are both moving toward each other at ground level. So when they run into each other, there's nowhere for the air to go except up. And of course, as a glider pilot, we love to find places where the air is moving up. The most common situation that will lead to convergence is a sea breeze situation where there's a cool water and warm inland land. The air tends to cycle along the beach and move inland from the over the lake or the ocean toward the land. If that situation happens at the same time that there is a general flow of air in the opposite direction, farther inland, then at some point a little ways in from the coastline, you'll get a point where those two air systems kind of run into each other and you'll get the convergence lift. So one way to spot that line, the two air masses will tend to have slightly different dew points. And as the air rises, when the air reaches the dew point, a cloud will begin to form, but it'll often begin to form at a slightly different height on one side of the convergence line than what it does on the other side of the convergence line. So when you see a big difference in the height of the clouds over a short distance, especially if it's kind of parallel to a coastline, it's a good sign that there's a convergence line right along that spot. This is a screenshot from SkySight on a day where convergence lift was happening along the Lake Huron shoreline in Michigan. This yellow with the red parts there are showing good vertical speed of air and good soaring heights along that region. So the last type of lift we want to talk about is wave lift. Wave lift occurs when there's strong winds blowing across a mountain or mountain system, and where the air is stable at the area where the near the altitude where the mountain peaks happen. When that happens, you get the air will of course have to move up as it goes over the peak and down again as it gets the other side. But the air doesn't then just start going straight. It oscillates up and down for quite a ways downstream from that. Those oscillations occur at altitudes a lot higher than the mountain peak and quite a ways downstream of it. So if you position yourself in one of the areas where the air is moving upwards and manage to stay in that long time, you can get to some very high altitudes. So one characteristic of wave soaring, these wave systems develop, they tend to be large systems that they span a lot of distance and a lot of altitude, and it's possible to reach some very high altitudes in wave, altitudes that are really unreachable in any other type of soaring. So there's some special things we need to think about when we are soaring at very high altitudes. One of those is supplemental oxygen. Supplemental oxygen is recommended whenever you're over 10,000 feet of altitude. The regulations require you to use supplemental oxygen anytime you're over 14,000 feet or anytime you're over 12,500 feet and stay there for longer than 30 minutes at a time. It gets very cold at high altitudes, even during summer, and even when the temperatures on the ground are very comfortable. So you have to make sure you dress for the cold, and also for simultaneously having bright sun, which can cause you a lot of sunburn. For flights that go over 18,000 feet, there needs to be a wave window that got negotiated with air traffic control. When there are wave soaring conditions, somebody that's organizing the wave soaring events will generally negotiate that, but there will be rules that go with that wave window. You need to make sure you have a briefing on what those rules are. Every glider has a maximum speed, or it's called VNE, never exceed speed. Sometimes the VNE is expressed as a indicated airspeed. Sometimes VNE is expressed as a true airspeed. So if you have a VNE expressed as a true airspeed in your glider, then you need to know what indicated airspeed would correspond to that true airspeed at different altitudes, because we'll need to make sure you, usually the indicated airspeed will be quite a bit less than that. So the types of clouds that you'll encounter during wave soaring are called rotor clouds and lenticular clouds. So lenticular clouds are kind of lens shaped, or they tend to be kind of a they have an uneven bottom, and they are they help you find where the wave is. Another type of cloud that you find is at a lower altitude where the air is going in a circle. Those are called rotor clouds. They tend to be more round shape, and both rotor clouds and lenticular clouds stay in the same position with respect to the surface features. Anytime that they are moving relative to the surface features, that means that the wind conditions are changing. The air near the rotor clouds is some of the most intense turbulence. I've heard people describe flying through them or even near them while they're on tow trying to get up into the wave system, and saying that turbulence can be extreme, and sometimes people need to get off tow because they can't keep right tension in the tow line.